Welcome everyone to week 3 part 2's video. I'll try to keep this short, but this is kind of putting all the pieces that we've been working on the last couple weeks together, drawing a map, determining how many cues there are, is it a temperature change or phase change, and then ultimately we're going to add them all together and determine how much total heat was gained or lost. So this is kind of the final piece. So I'll try to keep it quick when we go through the examples, but there's a couple of them and they just take a little bit longer. So bear with me, and if you have any questions, make sure you log into office hours or send me an email. All right, so here is the notes for week 3 part 2. Again, just really quick, when we're going through, we're drawing these maps, we're putting that min, we're putting the max, we're going to go through and we're going to put the phase change. And the idea is we're going to go something like that. We're going to get a Q1, we're going to get a Q2, we're going to get a Q3. And then the same thing could be, we could go Q1, Q2, Q3. Now, again, gained versus lost in terms of heat, right? We gained heat or lost heat. Now, what this part is going to deal with is this. What is the sum of all my Q? So what we've kind of done is we've gone through and we say, well, what is Q3? What was Q2 or what was Q1? And that's what I asked you to do in part 1 of this week. Now what we're really doing is we're putting all those pieces together. So when we talk about what is the sum of all my Q equal, I'm saying how much total heat was gained or lost during this whole process. And it's pretty straightforward. All we have to do is we take however many Qs there are, and that's why I've been having you draw a map with arrows and identify how many Qs there are. And in these cases, there are 3 Qs. So I'm going to go Q1 plus Q2 plus Q3. Now in this one, it's going to have positive Qs because they have positive heat gain and is plus or minus. And I'm going to have the plus because this phase change is gaining heat. And here it's still the sum of, so I'm still adding. But when you go your final temp minus your initial temp, you're going to get a negative temp. When you go plus or minus your phase change, it's losing heat. You are to choose for Q2 the minus M times L. For your Q3, you're going temp from initial to final. It's final temperature minus initial. You're going to have a negative Q3. So overall, you'll have a negative number. Again, a review on how to draw those maps. If you kind of forget, you need your memory jogged. And again, what's the difference between latent heat diffusion and vaporization is really the phase changes like we've been dealing with. And you're going to have to choose, is it the plus or is it the minus? Are you gaining heat or are you losing heat? So for this particular problem, we're going to kind of break it into 2 parts. So the first part is simply I'm going to ask you to draw what does the map look like and how many Qs, and is it going to be the positives or is it the negative? So map, we write our biggest number. So we have 2.6 kilograms of water, starts at 20 degrees and ends at 80 degrees. So then we got to look, is there a phase change that occurs between those temperature points? And the answer is no. So then what we do then is we can go through and we say, well, it starts here and it ends here, and we have 1 Q. And because it's going from the bottom left to the upper right, we are going to gain heat. And that's all this slide is really asking. Now, what we're going to do is we're going to use that exact same information in this part. So in this particular example, there was no phase change. It's just a temperature change. So when we go through and say, well, how much total heat was gained or lost, we're asking total heat gained or lost. We're looking for this. We're saying, what's the sum of all my Qs equal to? And in order to determine the sum of all my Qs, I have to go through and I have to add all the Qs from my map. Now, in my example, there was only 1 Q. So in this case, it's just Q1, and we say, well, is that the temp change or is that the phase change? And this is based upon the angled line, it's a temp change. It started at 20, it went to 80. My temperature changed. So then we can just say the sum of all my Q's is equal to MC delta T. And we can say the sum of all my Q's is equal to 2.6 times, now this is in the liquid state because it's between these two, on the melting point and the boiling point. So my specific heat is 4,186. And remember, it's final temp minus initial, and it starts at 20 and it ends, my final temperature is 80 minus 20. So when you go through and you sum up all, you take 2.6 times, you get a positive 653,016 joules. And that's it. For this one, problem number 2A, 3.2 kilograms of liquid aluminum starts at 660.4 degrees Celsius. Now, I am telling you it is liquid aluminum. We are just used to aluminum as being a hunk of solid metal, but this is in the liquid stage, and conveniently I picked it's at the melting point. So the idea is it's at the phase change, but we'll get to that in a second. And it ends at 20. So we have our map. We have 660.4. We have 20 degrees. We have temp. We have Q. And then we go through and we can say, well, where's my phase change? Well, my phase change is at the maximum temperature of 660. So really what we're doing is we're starting here and we're ending here. But what happens is we are going to do something like that. Okay, so we're going to go through a phase change first. So that's going to be my Q1. And then we're going to get this Q2. Hopefully you realize that we are losing heat. So when we go the plus or minus M times L, when we go the plus or minus right here in this phase change, you have to choose the minus. Okay, so we're losing heat and there's two Q's. So that's exactly what part B of this slide is asking us, is what is the total heat gained or lost? So the sum of all my Q's is equal to what? And in this case, we can say the sum of all my Q's is equal to Q1 plus Q2. And then we go through and we say, well, the sum of all my Q's is equal to, and we look at Q1, and it's plus or minus M times L. Now, there's two things we need to decide right now. Is this L right here, is it the latent heat of fusion or the latent heat of vaporization? These two go together. These two go together. So hopefully you realize by this point in time that this is latent heat of fusion. We're looking at these two together because we're at this 660. Now, is it gaining or is it losing? On the previous side, we said it's losing. So what that means is when we go plus or minus, it's going to be the minus. And then that's going to be plus MC delta T for our Q2 because that's a temperature change. So we then go through and we say the sum of all my Q's is equal to negative 3.2 times the latent heat of fusion of aluminum. If we look on the chart down below, that got messy, 397,000 plus MC delta T, so 3.2 times the specific heat of 899 times the final temperature. So we are only looking from here to here. So my final temperature is 20 minus the 660.4. That's running out of room there too. 660.4. Okay. Where's my minus sign? Sorry about that. There's a minus sign in there. So 20 minus 660.4. So when we go through and we do this, I'm going to kind of keep them separated. This is going to be the minus. We get a minus 1,270,400. And then when we go through and we take 3.2 times 899 times 20 minus 660.4, this is going to be negative 640.4. So we're going to get an overall negative number of negative 1,800,000. 842,302.72. And then when we go, I don't know what just happened. All right, well, we were at the final calculation, and hopefully you can just go rewind the video a little bit. Our sum of all my Q's when we are all done is going to be negative 3,112,720.72 joules. Okay, so that's my final answer. And that's the key, is we just go through, we draw a map, we figure out how many Q's, and then we go through. Now, what I'm going to do, I'm going to do something a little bit different with the next two examples. I am going to go through, and I'm just going to give you the answers. Oh, I'm going to tell you to, I'm going to say, pause this, here's the answer. And then we're going to go to the next one, and I'm going to say, pause this, here's the answer. Okay? And then if you don't get those answers, then I encourage you to go back and watch this specific part for that video, and it will be at the very end of these. So it will be like question number 3 and question number 4 after them. But my encouragement is then you can kind of try them on your own, and if you're good, you just move on to the next, and you don't have to like listen to me explain it. Okay, so here is number 3. 2 kilograms of water starts at 10 degrees Celsius and ends at negative 20. How much heat is gained or lost? You need to draw a map. You need to determine how many Q's. In order to, those are the steps you take in order to determine how much total heat is gained or lost. So go ahead and hit pause, draw your map, figure out how many Q's. What is the sum of all my Q equal to? All right, so when you go through and you drew your map, in terms of the number of Q's, you should have gotten 3 Q's. And when you went through and you summed up all of your Q's and you determined what the total amount of heat gained or the total amount of heat lost was, you should get negative 833,320 joules. Okay, so same thing with number 4. Number 4 says 2 kilograms of water at 80 degrees Celsius ends at 110 degrees Celsius. How much heat is gained or lost? How much total Q is there? The sum of all my Q equals what? So draw a map, determine how many Q's there are, and then determine the total amount of heat gained or lost. Go ahead and pause it. All right, so now hopefully you did that, and you're going to go through and in terms of number of Q's, there should be 3. Is going to be a positive. The sum of all my Q's is a big number in this one. It's 4 million. It is 4,727,640 joules. Okay, if you got that, good. Move on to your homework sheet called Temp and Phase Change, and then there's a quiz at the end. If you didn't get those, stick around and I'll walk you through these kind of step by step. All right, so now what we're going to do is we're going to go through and we're going to draw the map for this. So map Q T starts at 10 degrees. That's my biggest number. Ends at negative 20. So is there a phase change that occurs between there? Yes, at 0 degrees, there is a phase change that occurs. So we are going to start at 10. We're going to go down, Q1. We're going to go over. That's going to be my Q2. We're going to go down. That's my Q3. That's where my 3 Q's come from. So then when we say the sum of all my Q is equal to question mark, we're saying the sum of all my Q is equal to Q1 plus Q2 plus Q3. Now I'll kind of bust this into the things. For when we talk about Q1, we are only talking about that portion right there. And when we look at Q1, we have to decide, is Q1 water or is Q1 the ice form of water? So liquid or is it solid? So from 0 to positive 10 degrees, it is liquid water. So just keep that in mind. This is going to be an MC delta T, and that's for liquid water. When you go through and you talk about Q2, it's a phase change, right? So then we have to decide, is it latent heat of fusion or latent heat of vaporization, as well as do we have to determine, is it a positive or negative? And the direction of the arrow is telling me that this is a minus M, because it's plus or minus, right? So it's a minus, and it's M times L. And because it is at this phase change, it's going to be a latent heat of fusion because it's going from solid, liquid to solid. And then we will take the last piece and we're going to say Q3 is once again a temperature change, and it's only from there to there. So it's an MC delta T, and then you got to say, well, but now it's ice because it's below. So now we can start plugging in some numbers. The mass is 2. Now at Q1, this was the liquid water, so my specific heat is 4,186 times my change in temperature. Now, again, for Q1, my final temperature is 0, because a Q1 stops at 0 degrees, and it starts at final minus initial at 10 degrees Celsius. That's my Q1. My Q2 is going to be minus 2 times my latent heat of fusion, which when we look on our table is 333,000. Okay, and then we can go plus MC delta T. So we are going to go 2 times, and now we have to go through and say, well, we're only looking at Q3. Q3 is ice, so my C is 2,090, and then I'm just going to kind of wrap this over, times my final temperature, and this is my final right here, so that's going to be a minus 20, and then this is right here, my Q3 started at 0, so that's going to be negative 20 minus a 20. I'm sorry, negative 20 minus 0. So then we add up all of these Q's, and we're going to kind of break them into the pieces. The first part, the phase change of liquid water, was negative 83,720 joules. The phase change was negative 660,000 joules, and the temperature change of the ice was negative 83,600. And when we add all of those negative numbers together, we get a negative 833,320 joules. That's where that number that I came from was. Okay, now number 4, similar starting point. We start with a map. We have a temperature of 80. We have a temperature of 110. We're still talking about water. We have a phase change that occurs at 100 degrees. It starts at 80. It ends at 110. We have 3 Qs. We have a Q1. We have Q2. We have Q3. So when we say how much heat was gained or lost, we are saying what's the sum of all my Qs. And when we sum up all of our Qs, we go through and we add those 3 things together. So we then look at Q1, and we can say Q1 is a temperature change. And a temperature change, that's a bad color to choose. It's a temperature change, and we're only looking at the temperature change right there for Q1, because that's the only time it is a Q1. And we have to say, well, what is Q1? Well, it's water, but is it in the liquid form or is it in the solid form? And at Q1, it is from 80 to 100. It is in the liquid form. Okay, so just keep that in mind. But it is It's an MC delta T. Now, for my phase change, it's plus or minus m times L, and it is a positive because it's moving to the right, so it's going to be the plus m times L, and then we have to decide, what phase change is it going through? Well, it's going through the boiling phase, so this is going to be LV, latent heat of vaporization, plus then Q3 is a temperature change, MC delta T. And again, we are only looking at that part when we talk about Q3. So now we can go through and we can start plugging in numbers for these. The sum of all my Q is equal to mass of 2. Now Q1 is liquid water, so we're going to use the liquid water specific heat of 4,186 times my final. Q1 is only Q1 until 100, so it's 100 minus where we started, which was at 80. So that's going to be a positive 20, right? Then we're going to say M times LV, so 2 times LV, and my LV is 2,260,000. And then because I'm running out of room, I'm just going to go like this. And then we can go through for Q3 and we can say it's 2 times, now we are no longer liquid water. Okay, now we are in the steam phase, because between 100 and 110, it is no longer liquid water. We are now talking about steam. Okay, so we have to then use the specific heat of steam, which is 10 or 2010 times the, sorry, my times, there we go, my final temperature of Q3 was 110 minus my temperature that Q3 started at, which it started at 100. So the sum of all my Q's is equal to 2 times 4,000 times 20 is positive 167,440. Plus 2 times 2,260,000 is 4,520,000. Plus my Q3 is a positive 40,200. And when you put it all together and you add those 3 Q's, you get a combined total for total heat gained of 4,727,640 joules. So that's that. It's kind of putting all those pieces that we've kind of been working on the last week or two in drawing maps, and is it a temperature change, is it a phase change, and determining total heat gained or loss. If you have questions, come on into office hours or email me, please.